Good day everyone. This time, let's perform a bivariate analysis. Specifically, we are to perform t-tests, correlation or Pearson correlation, and chi-square test. Again, these tests depend on the type of variables that you are trying to associate or relate. We have t-test, correlation, and chi-square test. We are going to perform them. For t-test, we are going to relate sex or associate sex with reporting delays. For correlation, we are going to relate victim's age and crime reporting delays. For chi-square, we are going to associate weapon use and crime lethality. Now let us start with our JASP analysis. Let us move to JASP now. So we are now back into our JASP software. Remember that we have just conducted the descriptive analysis. Let's go to t-test. Let's go to the menu here above and let's jump to t-tests. You are presented with classical and Bayesian. We limit ourselves to classical analysis. Let's choose independent samples t-test. Remember that we are going to associate sex with crime reporting delays. So let's use independent samples t-test, because using this test we can compare two groups, binary groups or categorical groups, in terms of a continuous variable. Let's click independent samples t-test. So it is blank because we have no variables placed here yet. We have dependent variable and grouping variable. Grouping variable is our independent variable. Remember that in our research question, the independent variable is sex, so it is binary. It is considered as the grouping variable. And for dependent variable, the dependent variable is continuous variable, and that is reporting delay. So let's start placing in the grouping variable window the victim's sex. So let's start. Here, it's already here, victim sex. Then let's locate reporting delay in terms of minutes and move it to dependent variables. So we have now this result. What does this result mean? So let me interpret. The value of t is negative 2.334. Degree of freedom 438, because it is 500 crimes minus 2. Now let's go to the p value or probability value. This is very important here. The p value we can see here is 0.02, which means 2%. This represents the doubt as to the relationship of the two variables, or association between the two variables, sex and delay in minutes. Meaning, we have just 2% doubt as to whether the relationship is true or not. So we can confidently say that they are significantly associated. So we can say that sex affects delay in terms of reporting crimes in terms of minutes. And how can we say that we are confident that there's really a relationship? We can only say that there is a significant relationship between two variables by looking at the p-value. If the p-value is lower than 0.05, that is 5%, So if it is lower than point or equal or lower than 0.05, so we can be confident that there is really relationship or association between two variables, or our independent variable is really related to the dependent variable, or our independent variable is really causing the dependent variable, or that cause and effect. So there's really a link between the two variables. So here we can say that there is an association between sex and reporting delays. Either male have higher reporting delays or lower. But we do not know yet which has higher reporting delays, average reporting delays, or lower reporting delays. How do we determine whether it is the males or the female group that has lower length of reporting delays or higher reporting delays? Let's go back to the statistics box and let us look for the descriptives here. Descriptives, check it. So we have now the result here for descriptives. Female and male, number of females 256. So number of females, there are 256 females in the data, and victims, female victims and male victims 244. The mean or average reporting delay for female is 43 minutes, and for male 46 minutes. So that's the average. So the average for male is higher than female. So we can say that if the victim is male, the reporting of the crime is likely more delayed compared to when the victim is female. So that's the interpretation. So let's try to, so you can transfer it to your paper. So you can interpret it like this. Table so and so shows that the p-value is 0.02, which means that there is a significant relationship between sex and crime reporting delays in terms of minutes. And table so and so shows that the mean for female is 43.012, while for males is 46.119, which means that there is a higher reporting delays in terms of minutes, higher average of reporting delays in terms of minutes for male victims compared to when the crime or robbery incident has female victim. So that's how you interpret the table. Now let's go to person correlation. For person correlation, we are trying to correlate victim's age and crime reporting delays. So let's go to correlation. Where can we find correlation? Let's go to regression, choose correlation, then the variables that we are trying to correlate are both continuous, victim's age, and reporting delays. So basically we are trying to determine whether there is a relationship between the age of the victim and the reporting delays for robbery incidents. So let's start. Victim's age, place it in the variables window, and reporting delays, place it in the variables window. So here is the result. First column, these are the variables. Victim's age, number 1. Number 2, report delay in terms of minutes. In the column, second column, the persons R, and the p-value. Persons R and p-value. Persons R, this value 0.022, p-value is 0.625, as to victim's age versus reporting delays. So these figures 0.022, this figure represents the relationship between victim's age and reporting delay. We can say that there is positive, so somewhat a positive relationship between age and reporting delays, which means that when age increases, reporting delay increases because it is positive 0.022. The next question, however, is crucial. Whether the relationship is significant, or shall we say below 0.05. We can say that there is positive relationship, but is that significant? Is that below 0.05 or equal or below 0.05? The answer is no, because the p-value, probability value that we discussed earlier, p-value, what p-value means, is 0.625, and that is 62%. What we are looking is below, equal or below 5%, and that is 0.05. But here the p-value is 625. Now, so there's no significant relationship between victim's age and reporting delays. In other words, victim's age does not affect reporting delays. So whether the victim is younger or older, it doesn't matter. They have similar reporting delays. Now, you might ask, what does these lines represent between victim's age and victim's age? Logically, there's no number here because it is between victim's age and victim's age. So relationship between oneself. So there's no number. And here, reporting delays versus reporting delays. So there's no number also. So that's how person correlation is interpreted. Let's look for other variables. Let's add offenders age, then number of victims. Let's also add number of offenders, then that's it. So we have now this bigger table showing the different bivariate relationship: victim's age, reporting delays, age of offender age. But it's better for us to rearrange this table. Let's move reporting delays on top so that it's easier for us to interpret. So here, number one is reporting delays, victim's age, offender age, number of victims, and number of offenders. And the main dependent variable is reporting delay in minutes. Now, just look at reporting delays. Look at here. So reporting delays versus victim's age, the relationship is 0.022, but not significant, as I discussed earlier. For offender age, it is negative 9 point something, and it's not significant also because the p-value is 0.998, so that is way higher than 0.05, our benchmark. For number of victims, the relationship is positive but not significant also because it is higher than 0.05. The p-value is higher than 0.05. For number of offenders and reporting delays, the relationship is positive. However, it is not significant because the p-value is much higher than 0.05. But let us try, let's look at other variables, like for example offender's age and number of victims, offender's age and number of offenders. So we can see here that there are significant relationships between these variables: offender age and number of victims, and offender age and number of offenders, because of the p-value. The p-value for the relationship between offender age and victim number of victims is 0.04. So that is below 0.05, our benchmark. So we can say that there is significant relationship between offender age and number of victims. And the relationship is negative. What does this mean? The negative relationship means that if offender's age increases, number of victims decreases. In other words, if young offenders tend to target um, smaller number of victims or just one victim. So if the offender is young, there are few victims that they target in each robbery incident. So it is logical also, because they are young, they might not be that capable enough to subdue several victims at once. So they try to target one victim or few victims. How about offenders' age and number of offenders? The relationship is significant because the p-value is 0.003, and the relationship is negative because it is negative 0.133, which means that if offender's age increases, number of offenders decreases. In other words, younger offenders tend to collaborate with other offenders when they commit robbery, or older offenders tend to not collaborate with other offenders, meaning they operate alone for older offenders. So that's the meaning of the negative relationship. If one variable increases, the other variable decreases. In other words, here, offender's age increases, number of victims, a number of offenders decreases. So that is person correlation. That's how you interpret comparison correlation. Now let's go to the last bivariate analysis, and that is chi-square. In chi-square analysis, we are trying to analyze or answer the risk question: is weapon use associated with crime lethality? Crime lethality is the dependent variable, and weapon use is the independent variable. The dependent variable, crime lethality, is measured as binary, whether the victim was injured or killed, or not injured or killed. For weapon use, it's measured as whether the offender used a weapon or did not use a weapon during the robbery incident. So both of these variables are categorical or binary. So how do we analyze their association? Let's go to frequencies. Then contingency tables. Again, we are trying to determine the association between weapon use, this one, and victim harm or crime lethality as measured through victim harm. So let's choose weapon use, move it to rows, then victim harm, move it to columns. But you can interchange them, depends on your practice. Weapon use can be in the columns, victim harm can be in the rows. It depends on you. For victim harm, one means the victim was harmed. For if zero, not harmed. For weapon use, one represents there was a weapon that was used by the offender, and zero represents there was no weapon. So this is the contingency table. Victim zero meaning victim harm, zero meaning not harm. Weapon use, no weapon use, 98. For no weapon but the victim was harmed, 54. For victim was not harmed and there was a weapon, 172 robbery incidents. For weapon use, there was a weapon and the victim was harmed, 178 robbery incidents. So that's the contingency table. Now let's look at is there an association between the two variables? The answer is yes. Why? Let's look at the p-value. The p-value again represents the degree of relationship. We can say that there is significant relationship or significant association between the two variables because the p-value is lower than 0.05 or 5%. So here, the p-value of the relationship between weapon use and victim harm is 0.002. That is way below 0.05. So there is a significant association. We can determine the direction of association by looking at the contingency table. Here, victim harm, we can see victim harm 172, not harm, but for harm 176. For cases where the offender used a weapon, here, number 1. So meaning, if the offender uses a weapon, it tends to result to the victim was harmed. Look at this. If one victim weapon use 172 versus 98 if not used or not harmed, 92, and 54 here for no weapon, but for with weapon here 176 harm and no harm 172. So we can say that weapon use affects crime lethality. That means if there is a weapon or if the offender uses a weapon, it tends to result to more lethal robbery incident compared to when the offender did not use a weapon. And that relationship is significant. So that's how you interpret the association between two categorical variables. By the way, if you scroll up, you can see the previous results of your analysis: independence t-test, correlation, contingency. So that's it. In our next lecture, we'll be studying about multivariate analysis.